The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hello everyone and welcome to day 13 of Advent of Code. With me I have David. Hello.
Hello.
And before we get into day 13, and I really hope that day 13 is gonna be easy. Oh my god, this is killing me. Before we get into day 13, I want to share my failed attempt at finishing day 12. I want to hear about David's successful attempt at solving day 12, and then we get into day 13. So, first of all, my failed attempt at day 12. After the stream, just a couple minutes after the stream, I messaged David saying, ooh, this task of day 12 is actually very parallelizable because you can solve each line individually, independently, and then combine all the answers. How easy is it to make a Python multi-threaded program to solve this? And he said, oh, very straightforward. And in light of that, I decided, okay, I'm going to try it myself. And I didn't try it in Python, I tried it in JavaScript, and it was the perfect excuse to learn about service workers, which is what allows you to do CPU-intensive tasks in JavaScript using multiple cores. And I didn't know anything about that, so that was interesting. I have never used it before.
Can I interject?
Yeah.
Well, service workers are not for that. You should have been using web workers. Did you use web workers or service workers?
No, I said service workers, but I'm in Node.js, so I'm using neither. It's called...
A worker module.
No. It is called worker threads. Not service workers,
okay.
Worker threads. And
Got you. That makes sense.
in the documentation here for worker threads, they explain that you are supposed to not just create one thread per line of the file. You should use a pool of worker threads. And I found a neat little library called worker pool that does that for you. So I translated our program into JavaScript, and all I had to do was change the program so that it would spin this computation into its own worker thread using this worker pool thing. And I left it running since yesterday afternoon until now, a minute ago, and it was the semi brute force solution, the brute force solution that isn't being extremely naive, and the brute force solution that bails out early enough. And I left it running, and it did 238 or some. This is multi-threaded, so maybe a bit more or a bit less than that.
In a few days, it might work out.
Maybe not. So I left it running for 28 hours.
Could you show me your code?
Yes. And it could work out or it could not, because it was successful in some ways and unsuccessful in others. It was successful in that when I had the activity manager or activity monitor open, and I was looking at the 8 cores of my computer and what they were doing, when I ran my original code without multi-threading, without worker threads, it was only occupying one of the cores. And when I ran my new version, which I'm not going to do because it will mess with the stream, but it was maxing out all CPU cores. My computer was warm since yesterday. So it was successful in the sense that I learned how to use worker threads in Node.js. It was very
Yeah.
straightforward. It's very neat, and I'm even thinking of using that in CourseLore. So success there. Because right now I use multiple processes, child processes in CourseLore, and that consumes more memory, so that's a whole story. So it was successful in that sense. But it was unsuccessful in that it didn't finish in Monday, and I believe that it would not finish because there are some of the inputs that are just a bunch of question marks in a row, and that is very exponential. And Nick was saying yesterday on the stream, on the comments from the stream, that there is no way that that could work because it's like 2 to the power of 64, which according to my vague understanding of the complexity of this not so naive algorithm isn't really the case because I'm pruning the search tree early on, but it still is a lot of computation. So maybe if I left it running for long enough, it would finish, but I am giving up.
Yeah, but maybe like while you are pruning a lot of the search tree, it might have to. Worst case scenario is still 2 to the 64, and it could often get there. You know, like it tends to that complexity. Maybe I don't know.
Yeah, I don't
I'd
think
have
it
to
is the
inspect. It
case
depends on the input.
because I am not, even if it is just a bunch of question marks in a row, there is this that helps us prune the search tree earlier.
Yeah, but worst case when there are really like, let's say there were millions of permutations per line, then it would be 2. If it was just question marks every time, it would still be 2 to the 64 every time, right?
No, not
I guess
really.
there are
And
still,
there are some inputs that had millions of. It perhaps would be interesting to look at the maximum that I was able to compute with brute force. But look at this one, for instance. This one has.
I can't see your screen, sorry.
Oh,
We'd also like to see the code for it.
yeah, I was showing you the code all along.
Yeah. Sorry, I should have interrupted earlier.
Yeah, so this one, for instance, it has almost 2 billion arrangements. And I was able to compute this with brute force. So my algorithm is slow and terrible, but it isn't so slow and terrible, even for billions of things. This one may even be 4 billion.
Right. Well, these are, I guess, some of the shorter cases, right? Because it's parallelized.
Well, it is parallelized as in each line is sent to a different core.
Yeah.
And I bet that my 8 cores were working on on examples that had billions of arrangements. And I am showing the springs here as a simple line, but actually this is multiplied by 5 in my code. And now, with you being able to see my screen, I will show you that there are indeed cases in which the line starts, and then there are a bunch of question marks, and then a space. So there are 3 cases in which there is just question marks all along. So you could say that the longest of these 3 cases, which happens to be this one, could be exponential. Well, it is exponential, but it could be way, way, way too much work for the machine to do. But I would argue that this helps you prune the search tree a bit earlier, so it's not so.
I wonder how it would be interesting to work out how long it takes for that one to run. To take the longest example, and the worst case with all question marks, and take the worst case, see how long it takes to run, and then see how long it would take to run all of them. But let's just have a quick look at the code. So promise.all worker.execute this function. And that's it?
That's it. You have to create a worker pool. Then you have to say workers exec, and this is going to be sending jobs, different workers in different cores. By default, it will use the number of cores on your machine. So there were most probably 8 workers. I haven't checked. But then you just send the workers off, and then you can return from the workers. And this will return in this promise when this promise gets resolved. So then reduce with a plus, and then terminate the poll. So it's as simple as that. So
that's pretty amazing. But how does it deal with shared memory? So what if you try to modify a dictionary?
Well, There are two answers to this. My first and more principled answer is that you don't share memory. You pass in everything that the function is going to need, and you pass out everything that it returns, so there is no shared memory. But if you need, you can share memory. There are even special data structures in JavaScript for that. There is the shared array of bytes or something.
Buffer.
Something.
Shared array buffer and atomics, I guess, as mutexes.
Yeah.
But I would be interesting to see like what happens if you try and like modify things.
Yeah.
And is it, I guess it's just like last write wins, or it's like undefined behavior.
I'm pretty sure that the data structures in Node.js are not thread safe, because why would they be?
Yeah.
Node.js is single threaded. So if you start messing about with data that is not one of these shared data structures, all hell will break loose.
I'd like to see all hell break loose.
Yeah.
But that's very cool. Yeah, take a look at the link that I sent.
Yeah. So and not only I worked on this, but I also spent the whole day today. I was at Hot Springs, incidentally, which is cute because all the hot springs that appear in the problem. And I spent the whole day, like, when the conversation died off, I started thinking about the problem and thinking of potential solutions. I came up with nothing. I was ready to let this problem rest and do day 13 and come back to it in January. But David saved us this time with this solution. So
I'll let you read it.
Let's read it. Okay, so you have the ways. That's similar to what we had yesterday. Then you're going.
Not much has changed.
Huh?
Not much has changed. This first little section here, it's all the same.
Okay, so you are not doing anything with the expected and the chars. You're just multiplying them. So I was thinking perhaps the solution is to build up from the solution for one of the segments and take advantage of the similarities or the symmetry of the problem. But you're not doing that.
Well, line 2033 is very important.
You're caching, and what you are caching is the sub-problems. You're memoizing the traversal.
Yeah.
Is that all?
Yeah.
Fantastic. And how fast does this run?
Like, pretty instant, to be honest with you.
Interesting.
Yeah.
Why did you come up with the idea of memoization, and why does it work?
I just thought, like, this is very memorizable, right? Because if you think about it, it should be composable in that sense, right?
It's absolutely memoizable because this is a pure function. Given the same inputs, it will produce the same output. There are no external things, except maybe for the ways plus one. But I suppose you're doing something about that. You change the function so that it returns the ways, like I did. When I implemented it again, I said that I didn't like the global variable, so in my version, it returns. And I also wrote my version so that it's one big S.
And also, it wouldn't be thread safe, right? If you were mutating the global. In
Absolutely, yeah. Good point. And in my case, I was neat, and I made this one big S ternary operator, a bunch of ternary operators. But
lovely.
What you're saying is, so I absolutely agree. It is very memoizable because it's pure. But why is memoization useful in this case? That's a question that I don't know how to answer.
Because you many times, if you think about it, like many times you're going to be sending this with the same arguments, where the chars and the expected and the previous char are all the same. And like even for a case where it's like eight permutations that you're generating, you can instantly just like exit out of that. And they often just keep reducing down to the same,
I don't see that. Because here's my thinking. I have all this extra work that I will have to do later, right? And then in the beginning, I will find a question mark, and I will either put a dot or a hash there. If I put a dot, then I don't consume expected. If I put a hash, I consume expected. So when I get to the rest of the work, I have different expecteds. So I will not be using the cache. So in my head, it's always a cache miss.
How is it always a cache miss? Sorry, the cache is shared between all the inputs, by the way.
Yeah, I noticed that. But even then, only if there are similarities between lines that you're leveraging any extra work. And even not even that, you have to have shared stuff, shared sections, let's say, between lines, and shared expected between lines as well, because the cache key contains the expected.
But you're decrementing the expected a lot.
True, but that is conditional to what I do in the question marks.
Yeah. Well, I guess I don't have a provable, like I don't have a way of explaining why it's super likely that they will have some overlap, but I guess it is.
Do you think that the inputs have been constructed in such a way that they are reusable in the way that I explained? Like maybe hidden in here, there is some sort of pattern where you will see this line again, but with one extra question mark 100 lines below? Like the solution for day 8 is really kind of almost like they had the idea, I want to use LCM, so let's build up on that. And here they like, oh, I want to use memoization, let's build up on that.
Maybe. Maybe the inputs were constructed in that way. But I also just feel that like there isn't that much entropy between these, like, because there aren't that many states.
That's amazing. So, in light of...
I mean, maybe there is a provable way of saying that there is a...
In light of that, you know what's coming next? It's such a simple change that I will have a cache here that will be a map. I don't need anything in the map to begin with. And I suppose the best way to do... How did you write this?
Use the tuple as an index, but you could just concatenate into strings.
Yeah, no,
I
I'm
guess.
fine with that. I'm thinking of how am I going to do the cache updates.
Oh, before I return the answer, I just store it.
Let me see how...
On line 2058, yeah.
Ah. Okay, you first do a cache lookup. Okay, I think I get it. So you have, and does that need to be an auxiliary function in of itself? Yeah, it doesn't hurt. I guess I can put it here. And now I will comment out my worker stuff. Even though it was super useful to learn about this. Like so. And then you're telling me that all I have to do is come here and come up with a cache key, which is going to be JSON stringify of, or maybe even...
What are the springs? Oh yeah, I forgot this was about springs. Yeah. Yeah.
Then I if cache has cache key return cache add cache, no, not like that, get cache key, then these are arrangements. And you promise that this is gonna run fast?
I promise.
Do you pinky swear?
Yeah. The confidence. Well, if you type the module name correctly, yeah. You didn't run the right file. I guess you workers somewhere. Oh yeah. I guess you can just delete those. Or,
Yeah,
comment.
I'll just delete those. Don't really care about that code. It was easy enough to write.
I guess you'll need to. Yeah. Okay. What happened here? Did you just concatenate the file?
It's printing a lot of stuff. I may be doing something
There
silly
must be
here.
a syntax. Oh yeah.
Oh yeah, I'm printing all the outputs.
Hey!
Jeez Louise! I guess I will remove my console logs. And I don't need a line number anymore because I'm not printing it anymore. Wow! Now, is this the correct answer?
Let's see.
Wow! Color me impressed, David. Good job! What the hell has happened here? I really don't see it. And you told me that you also understand the solution for day 8, which I tried to explain to the best of my ability, but in explaining it, I noticed that there are many holes in my understanding. So can you explain to me why memorization works here? Or maybe even why you came up with the idea. Why did you come up with the idea to memorize? And how does day 8 work?
So, I mean, memorization, I don't have much more of an explanation other than, like, it just seems very memorizable.
Okay.
And maybe just introducing, it's just the idea of, like, we're going to be recomputing the same thing many, many times, and that it will reduce to the same thing. So I just thought I'd give it a go.
Well,
basically.
I guess you are right, because the thing that I was explaining, if you put a dot or a hash, it will change your expected. That is true. But if you have 2 question marks in a row, and then you do dot hash or hash dot, you will, from then on out, have the same sub-problem. So caching that is advantageous.
Yeah, especially as you're reducing the problem every time. Like, because the problem's getting, the chars are just getting smaller each time.
Now that makes more sense to me. So yeah, the idea of going from left to right instead of trying to come up with permutations and then compute their checksums, that seems to be important for memorization to work.
Yeah, I couldn't have memorized the first solution.
So with our brains put together, we are able to solve. This is beautiful. I love it. The metaphorical resonance.
Exactly.
And this is a problem that I appreciate. Unlike problem 8, which has some tricky inputs, this one I appreciate. It has some elegance to the problem and to the solution. I love it.
So, yeah. As for day 8, I'm not sure if you said it in that Excalibur or not, but the only way that it can work is if we just... The end node offset from the end of the cycle is the same as the offset at the beginning. If that's true, then it just becomes... That's why LCM can work. The only way that LCM can work is if the offset doesn't matter.
What is the offset in this sentence?
The offset is the offset of the cycle.
Do you mean with respect to the directions?
With respect to this, so there's the start of the sequence, the start of the cycle, and that's the offset I'm talking about.
Okay.
And then there's the end node, which is within the cycle, and then the length of the cycle. Now I haven't verified this, but as long as the end node, as long as it's like the same offset from the end of the cycle as the offset of the beginning of the cycle. I mean, it's much easier if I drew this, but
Do you want to? Do you want to Excalibur draw real quick?
real quick, yeah, okay, share it with me. It's not.
Do you want to? I have this drawing here. Do you want to be able to jump in here?
Yeah. So what were your claims here? End node is at the end of the cycle. No, it's not one of those. Yeah, share it with me quickly. Do I have access? I'm not sure.
I don't think so.
Yeah, send that to me. Well, the main thing that I realized is the only way that that LCM can work is so like we have this is the obviously the start. This is the end node here. And obviously this is the end of the cycle. And there's this offset here and this offset here. You see?
Mm-hmm.
This is the offset from the end node to the end, and this is the offset from the start of the cycle to the beginning.
Mm-hmm.
And I claim, although I've not verified it, that these two are the same.
That makes more sense than my attempt at explaining it yesterday. And even this first drawing doesn't really hold.
Yeah. So if these are two of the same, then it makes sense that you can ignore this.
And it also is more compatible with the example input, in which we do see a final node, and then we see it appearing again.
Yeah. So what happens is what we did is the LCM of this portion, which is the same as this number, isn't it?
Mm-hmm.
When you think about it, which is why you don't need to think about this anymore, or equally you could say you don't need to think about this section. That's my understanding of why it works. But I haven't verified that. But that's the only way that it could really work, right?
Well, I have verified it, and you have verified it with the example inputs. That's the case with the example inputs.
Right.
We did that together. Yep. So lovely. You are on a roll. I feel bad that I'm driving today because you are on fire, David.
I have one more revelation, which is about day 10, which is probably my favorite problem so far.
Yeah, you said that you tried something and it did not work, but tell me more about it.
I think it's in Excalibur. I'm in Excalibur. So my thinking is to do the ray tracing, but just in rows like that.
Mm-hmm.
And what we'll do is path in here. Whatever. And if you just hit, if you're just going like, if you're just going, just maintain, you start on the outside always, and then you're inside when you hit one, and then you're inside until you hit another one, and then you're outside. As we said, this is the simple case, right? And we're fine with that. The only difficulty is with the case where you're going along a wall, right?
Yeah.
And my thinking is, it's just when you exit here, when you've been going along a wall, all you have to do is look up at this row here. And if this row is inside, then you're inside, right? And it, like, for example, here, we're going along. As soon as we exit, we just check, is this row inside? Yes, it's inside, so therefore I'm inside. I don't need to inspect the corner or the loop or anything like that. I just need to look at the row above, because I've already labeled the row above, because I'll be going through every single row and I'll be labeling inside and outside for the simple cases. And then when I hit a wall, I just need to look above. And obviously, if you're on the edge of the thing, if you look outside the board, then it's outside, right? And I think this works, but I tried an implementation and then it didn't work. But then I have some confidence in this. but I don't know. I haven't. I don't know if you agree with that
Well,
on a
I
fundamentally.
think it is sensible, but for the sake of funsies, I will try and come up with a counter example, and I will devote all
Okay.
30 seconds to that. So we'll see how
Yeah.
it goes. The real problem is I am inside, and I see a parallel wall, and then I will now go either up or down. If I go up, then this will be outside. If I go down, this is inside, counting that this is inside. And then what you're claiming is that I will arrive here at this point, and I will be able to look up and have my answer. So for instance, if I do this and I look up, I'm inside, that's all right. And Command Z doesn't work because we are sharing. And if I do that, then I look up and I'm outside. What happens if I have a wall right above? Oh, it doesn't matter because the previous line has already computed the answer.
Yeah.
Okay. I see. And what happens in weird edge cases in which I am like, boop, 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 something like that. Then again, I can reuse the answer from above.
Yeah, kind of. This might not work because you might look and you say, oh, well, that's in the path, therefore it's inside, but it's actually not if it's outside. So say, for example, the path was, this might be my, like, where it doesn't work. Oh, no, I can't.
You can't undo it because you're in a collaboration session.
Yeah, I don't know. Undo works really badly at the moment. But yeah, so here, even though I look upstairs or up a row up, it's inside. I'm actually not inside. I'm outside. So that is the issue with this. But I still feel like it might be. Yeah, I'll have to work on it more.
Well, the real problem with this idea is that, in general, when you see a parallel wall, it may resolve itself either by going up or by going down. And we are looking at a point that is right about there. So the problem that I see with your idea is that if the wall is resolving by going up, then the new dot is separate from the dots you have seen along the way. And if it goes down, it is contiguous to the dots you have seen along the way. So you're only able to distinguish these two cases by observing what was the shape around here in the beginning and what is the shape around here in the end.
I don't see that issue. But let's get on with day 12 before we run over. Oh, day 13, sorry.
Yeah, forget about day 12. My friend solved day 12. I want to do day 13. And you were driving yesterday. I remember this right?
Yes. Yeah,
so day 13, point of incidence. Here we go. And here's hoping for an easy day 13 because fucking hell.
It's already 20 to 11.
With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. Did you notice that the drawing that we are doing is our story, where we used like a stairs and then there was like a desert island and then we go up?
Wow, no, I didn't notice that.
There's just one problem. You don't see any lava. You do see a lot of ashes, a lot of ash and igneous rock. There are even what looks like a gray mountains scattered around. After a while, you make your way to a nearby cluster of mountains only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction? As you move through the valley of mirrors... Oh no, these shapes again. As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk and where you're about to run into a mirror.
Mm.
This is a contrived setup. Note down the patterns of ashes and rocks that you see as you walk your puzzle input. By carefully analyzing these patterns, you can figure out where the mirrors are. For example, she blinks. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows. So a horizontal line between two rows would be, for instance, right about there, which happens to be the real solution for this problem, as we are about to see. Or across a vertical line between two columns. I'm not to solve this one just by looking at it. I think perhaps around here.
Mm-hmm.
Yep. In the first pattern, the reflection is across a vertical line between two columns there. Oh, and maybe the one that I saw first is not correct.
Well, I mean, it does look like a reflection, but it's kind of uneven, right? But I don't know if that's relevant.
Oh, it's not a reflection because of this. But the vertical one is a reflection.
No, that is there. That thing you just tapped is there.
Yeah, it's here.
Yeah, anyway, let's keep going.
Perhaps you could argue that it's not a reflection because this one below has an extra line.
Yeah, that's my thinking. But also the one on the left has an extra column.
Yeah, so oh well. Or maybe there are multiple reflections. In the first pattern, the reflection is across a vertical line between the two columns, arrows of each of the two columns pointing at the line between them. Okay, so it's just showing what we saw. In the pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, as we observed column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Column 2, for instance, matches column 9. The second pattern reflects across a horizontal line instead. So we are now looking at this, and I suppose the reflection will be about there. But I'm still curious as to why this doesn't reflect on the horizontal line, because it seems like it should. Maybe it's this guy? No, again, I'm getting confused by the lines here.
Oh, it's the last.
Oh, it is this. It is this one. That's why it doesn't reflect.
Oh, yeah?
Yeah. Oh, look at it this way. You see it? You see it?
Yeah.
Okay.
Yeah.
Okay.
Yeah, I see it.
Okay. The second pattern reflects across a horizontal line instead, which is this. This pattern reflects across the horizontal line between rows 4 and 5, row 4, 1, blah, blah, blah. To summarize your pattern notes, add the number of columns to the left of each vertical line of reflection. So, for instance, in this case, add these, which I guess is 5. And also add 100 multiplied by the number of rows above each line of the reflection. This multiplication is just to keep the number of columns separated from the number of rows, I suppose, above each line of the reflection. So this would be 4. So for instance, this would be 400 plus 5, 405, which is indeed what they say in the end. So in the above example, the first blah, 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 what we just learned. Find the line of reflection in each of the patterns in your notes. What number do you get after summarizing all your notes? So I suppose each input will only have one reflection, either horizontal or vertical. And will the puzzle inputs be completely crazy? No, they are all relatively small. There are many of them, but they are each manageable.
What? This would be great to solve with Vim. I don't understand. I don't fully understand why the reflection worked. Could you show me one of the examples again? Because it looked to me like on the first example there was an extra column. So how could it really reflect?
Well, extra columns may be ignored. So
Is that what it said? If they can't be reflected, if it's an odd number. So if it's an odd number, then you can ignore the reflection. So I guess we can just make it.
well,
Or is it odd or even?
that's an interesting question you ask. I suppose if we found, for instance, a reflection, or let's say it's not even a reflection, if line 1 and 2 are equal, I shouldn't say lines because we are dealing with one that has vertical reflection. So if columns 1 and 2 are equal, you could say, bam, I found a reflection. Columns 1 and 2 are equal, and the rest of the lines, god damn it, the rest of the columns may be ignored because I found a reflection between lines 1 and 2. Columns 1 and 2.
Yeah.
God damn it, Leandro. You see what I mean, I hope.
Yeah.
Great.
Yeah, I think that makes sense.
Okay.
And then equally, if you did it on the last column, 2 columns, you could, if the last 2 columns were equal, you could also ignore the rest.
Yeah, that is my idea.
Okay.
So let's start this live share. Create 13.
Let's do it. Do you want to say what your general strategy is going to be?
My general strategy is to simply look, is the reflection between lines 1 and 2? Is the reflection between lines 2 and 3? Is the reflection between lines 3 and 4? And so on. And to detect a reflection, I will do what they are describing here. If I suppose that the reflection is between columns 5 and 6, I will check, is column 5 equal to column 6? Is column 4 equal to column 7? Is column 3 equal to column 8? And so on and so forth. Simple as that. Brute force, my friends, brute force. So I will have my sum. I will do the parsing, so I will get a board. Do they call it boards?
Board's a good name, though.
Board's a good name.
Because-
I like board. So for board of input, trim, and split on 2 new lines in a row, I will map each of the boards into a convenient data structure. So this is a board string. My convenient data structure will be a board string split on the new line. And I will map each board string line. And I will split on nothing. So I get boards in this convenient way,
Beautiful.
which seems correct, but is it really? The printing is awkward, but
Yeah, it is awkward.
the printing is awkward, but the structure is there. It's just it's
Yeah.
wrapping in an awkward manner, but that's all right.
Mm-hmm.
Okay with that. So I have a board. Let's check for, are the boards always squares? No, that would be convenient, but no. Let's check for horizontal. Add up the number of columns of each vertical line. So let's check for vertical reflections first, which means that I will traverse this on the x-axis, looking for vertical reflections. And then I will do the horizontals. So I'm now looking for vertical reflections. Therefore, I'm playing with the x-axis, and my x of reflection will be going from, well, these numbers are a bit awkward because they start at 1. So
that's all right.
I guess I will do everything 0 indexed, and I will add 1 in the end. So I will leave a note for future Leandro. Remember to add 1 to the coordinates.
But you have to shout it, don't you, if it's all caps?
Yeah.
Future Leandro.
And my x reflection will be the index of this left guy. So in my case, it would be the number 4 because I'm starting counting by 0. So it would be the reflection is like right after me.
Yeah. I mean, they say it's the first column, and you could just return the second. Do you see what I mean?
I see what you mean.
But whatever.
For computing
we'll get to the plus ones.
For computing this, no. I think it's smarter if I do it, if I make it be this guy. For reasons that will become apparent when I start adding indices all around. Because I will have fewer plus ones around if I use this guy. So I will use this guy, which in my case will be the number 5, because I will start counting by 0. And it makes sense that they start counting by 1 because you want to make sure that if the reflection is in the beginning, the reflection will not be in the beginning. So it doesn't really make sense. It's just confusing. Anyway, I will use this guy. So my reflection is right before me. So the index of reflection must not be 0 because I will not have a reflection before the beginning. But it may be 1 because my number 1 is right here. And then the reflection could be this. So it starts at 1. And my reflection must not be after the end. Looking at this example will confuse me because I already have this note. So what I'm going to do is real quick do this. And therefore, when working this out, I want to look up to number 8. So in this case, I want to go up to length minus 1. Or maybe x reflection less than and not less than equal. What is my board at 0 length? X of reflection plus. And if I did all this right, then my x of reflection should go from 1 up to 8 in the first example. And it does. Excellent. Now, for, let's say my x of reflection is 5, like in this example, what I want to do is check for. I will want to check columns. So maybe my data structure is a bit awkward here, but we'll see. I will want to check for, let's say that I have an x reflection offset. So for a latch of x reflection offset, it will start at 0 and it will increment. But the condition of stopping is a bit less straightforward because I want it to be the minimum between 8 and 5. So board length minus x reflection and this much, which is simply x reflection. Okay, so it wasn't so awkward after all. And in this case, I do think I need a +1 in this guy. But let's see. 8, which is my board length. No, my board length is 9. I'll stop confusing myself here. Is equal to 9. So 9 minus 5 is 4. So that checks out. And this is 5, which is that number. So that checks out as well. Excellent. So with that, I expect to have my X reflection offset between 0 and 4. Well, I should say that, shouldn't I? Well, maybe I said something wrong here.
So this is the minimum of the starting index, as it were, or that so you're moving along the reflection.
Nothing like a good less than greater than switcheroo, right? So yeah, well, I was playing out with a single example here, but in the general case, there will be a bunch more of those. So I'll not bother with that and suppose that I got it right. Let's move on. And okay. I will want to check columns in this case. So I will need to go over a y-index, which starts at 0 and goes all the way up to the board length. I will also compute my x, which is my x of reflection. No, I shouldn't compute it here. I take it back. So if it is the case that my board at y at the x reflection plus the reflection offset is different from minus my reflection offset. If it is different, then I found a proof that it does not reflect. And therefore, I want to bail from here. I want to continue here. So, how do I continue 2 for loops above? I think there is not such a thing as a JavaScript continue label.
I would generally put it in a function and then return.
That is a good call. Continue outer. Use labels in JavaScript that are mainly used with break or continue or nested loops. Excellent.
Wow.
Here's something you don't see every day, folks.
I learned something new. Wow.
So what I want is to bail out from this guy, so I should get back here. It will go to the next iteration of the outer loop. So I want the next iteration of the X reflection. So I will label this, and this is like a reflection not found label. And in this case, I want to continue there. But if I get to the end of...
Oh, wow. This is so esoteric. You never see... I think if somebody read this, they'd be like, what language is this?
But if you look at Svelte, do you know of Svelte?
Yeah, yeah.
They use this syntactic feature of JavaScript for something completely different. They compile this into something completely different, but syntactically, that's what they use. So that's why your syntax highlighter works and stuff.
Yeah.
Which is good stuff. So, now, if we got to the end of this intact, then this is a reflection. So, I will I will sum my, god damn it, I don't have my X reflection anymore, do I?
Yeah, you should do. And then you should break as well.
Oh, yeah, I should. I'm inside.
And then break.
And then break, you say?
Because you only have one reflection.
Well,
Yeah.
no, continue, because I want to look at the next board.
Yeah. But you want to break out of this board.
I want to continue because this is the for loop. Wait a second. No, I want to continue this guy.
Which, right, yeah.
So what I call reflection not found label really should be like vertical reflection search or vertical reflection search, while this is the board's exploration. Ridiculous. I will continue my board's exploration, which, I mean, this line doesn't read terribly.
Yeah.
Neither does this. So it's not so bad. Now, if I got this right, then I should be able to find the reflection in my first example board, which, as you all know, I need to remember to add 1 to the coordinate. So let's do that right now. And the result of this should then be the number 5. Should be the number 5. If I did everything correctly, we should see a console log of the number 5. And we see a number 0. So that didn't work. Could it be some of the indices, or could it be the continuous shenanigans? Well,
I don't fully grasp this math.min, but you seem pretty confident about it.
Well, the idea is that I want to ignore, for instance, in this case, I have 4 elements to my right, I have 4 elements to my left, and I want to ignore number 0. How do I do that? And thanks for asking, by the way, because it's this kind of thing that will help me find the problem. My idea is that I want to take the minimum between what I see on my left and what I see on my right. So perhaps I should reorder these two, because it doesn't matter and because it will make the thing perhaps more readable. So the thing on my left is 5 elements, because my idea is that I'm going to start here at the reflection and I'm going to go both ways. I think I found the mistake already. This offset will start at 0. So I will want to offset 0 to the right, but -1 to the left. So I need a -1 here. We will see. No. So my idea here is the thing on the left is 5 elements. So it is simply this number, X reflection. And the thing on the right is the length, which is 9, minus my X reflection, which is 5. So it is, I'm missing a +1, aren't I? Because 9 minus 5 is actually, no, 9 minus 5 is 4. Okay, I have 4 elements here. That checks out. And then this bit is going from like the inside out.
I see. Yeah, I see what you're doing, yeah.
So this X reflection is going to be 5, the F set is going to be 0.
Here you just want to work out the length of the reflection.
Yeah. And then this should
or at
be
least
X
like
reflection
the
minus
radius.
X reflection offset, which to begin with is 0, then -1, which is the number 4. So that should check out. And then when I say that X reflection offset is 1, then I'm going to say 5 plus 1 is 6. And 5 minus 1 is 3. Okay.
Yeah, very nice. I think this should work.
I agree. But there probably is an off by 1 mistake or something like that. So let's see. My reflection, X reflection, starts at 1 and goes up to, but not including, 9. So it could be the number 8, and then the reflection would be right here before the number 8. And I like that. Then my X reflection offset starts at 0 and goes up to that I just explained and we agree on. Then it goes up.
Is it less than or equal to? Should it be less than or equal to?
Let's check. If my minimum is going to be the number 4,
Yeah.
then it should be 0, 1, 2, 3. Maybe you are right. Maybe it should be like that. Does that work? Yay! I got something.
Yeah.
Which is not
That's
the
number
response I
6.
expected.
It is. You shouldn't have to add the +1 to the X reflection because we're doing 0 indexed.
I got the number 5 now, but I don't get it. I don't understand it.
What don't you understand? Because they ask for like the one after.
They ask for how many lines there are to its left. So in the example that we are working on, there are 5 lines to its left. But because we are indexing by 0, we get that for free.
Yeah.
Lovely.
Yeah.
Good job, David. Thanks.
Good job, you.
Well, you found my mistake, and you also found my second mistake. And you're finding many mistakes, is all I'm saying. Now let's rinse and repeat for horizontal symmetries.
Yeah.
So, after all of this, I will get my vertical search. And I suppose I should have a sentinel here for whether my vertical search succeeded. So vertical reflection search succeeded.
Yeah, so can it have vertical and horizontal reflection?
No.
No, okay.
And if... wait a second. If my vertical search succeeded, I'm already continuing the board exploration.
Yeah.
So I'm silly. I should be able to just copy this block and start working on it. And I guess I can remove this. So now this is not the vertical, but the horizontal. So for X reflection becomes Y reflection. And it doesn't go to the board length, it goes to the board length. The X reflection offset becomes the Y reflection offset, which in this case is probably simply this. Then my Y becomes my X, which goes up to that. And this...
I don't...
No, this actually stays. No. We are first offsetting into Y. Indexing into Y is what I meant to say.
Yeah.
And then this we multiply by 100. And this is necessary because we want to bail out of the horizontal reflection search. And I will maybe call this vertical and this X. I'm okay with that. Perhaps a bit awkward, but it is what it is. So now we get 405, which bam, 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 bam.
All right, let's run the real deal.
Let us.
It happens to me all the time. That was quick. Hey! Fireworks. Very nice. Now, for the
Part
real.
2. You resume walking through the valley of mirrors and smack. Run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge, exactly one dot, or pound should be the opposite type. Okay. In each pattern, you will need to locate and fix the smudge that causes a different reflection line to be valid. You need to locate and find the smudge that causes a different reflection line to be valid. So there will be a different reflection, not the one we found, that will be an almost reflection if it isn't for one mistake. The old reflection line won't necessarily continue being valid after the smudge is fixed. So I think I understand, but let's see. Here's the above example again. The first pattern's smudge is at the top left corner.
What you noticed the first time.
So let's see. We are looking at this. We find a reflection here, and then there is this guy that doesn't correspond to that. But if this turned into a dot or this turned into a pound, then it would have worked. Let's see if they agree with that. If the first pattern is blah, 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 if the top left blah were inserted instead of dot, it would have a different horizontal. And it doesn't really matter which one we fix. The smudge could be the one in the top or the one below. It doesn't matter. With the smudge, in the top left corner, repaired a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflected row and can be ignored. But every other row now matches exactly. Row 1 matches 6 and so on. In the second pattern, the smudge can be fixed by changing the fifth symbol, blah, blah, blah. Now the pattern has a different horizontal line of reflection between rows 1 and 2. Summarize your notes as before, but instead use the new, different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above it, and the second pattern, new horizontal line, has 1 row above it, summarizing to a value of 400. How so? Because now both are horizontal. In the pattern, fix the smudge and find the different lines of reflection. What number do you get after summarizing the new reflections line, blah, blah, blah. Okay, we got this, people. We got this. This is an easy day after all. Hooray! Don't say that too early, Leandro.
So what happens to the... So I didn't understand what happens to the old reflection.
It goes away. It may not be valid anymore. It won't be valid anymore, and that's
So you have to find a smudge.
Yeah. So the way that we are going to find a smudge is we are going to do our search as before, but we are not just going to bail out. No. We are going to count how many mistakes we found along the way. And if we found exactly one mistake, then that is our reflection, because that's the smudge that we would need to fix. So let's find 4.
What's the complexity of that? Is it still...
Very
I'm just wondering,
linear. We are just going over the inputs once.
Yeah.
Today, this program is not going to run slow, David. Today's problem was easy. Let's count our blessings. So this is my reflection search. I am supposing that the X reflection will be in a certain place, and to determine that, I will find my mistakes. Or I will even say something like smudge found. For reasons that will become apparent.
My intuition was to try changing.
Oh, what am I saying, David? No,
cell.
we don't go over the input once, because we are iterating over here, and then we are iterating again over here. So we go over the inputs, I want to say quadratically.
Yeah.
O of n squared.
But my thinking would probably be a lot slower. My thinking was try modifying every single cell until we find a reflection, and that would add another level of squared to this complexity. Whereas this doesn't. This just finds that. So it's really smart that you went straight to that.
Thanks. So my smudge false. I have not found my smudge yet. And if the thing is different, now, if my smudge has not been found yet, then I found my smudge. But else, if my smudge has already been found, then
Don't forget your curlies.
no, not necessary.
Really?
Really. As evidenced by the indentation created by Prettier. Because there is a single statement inside each clause. But let's see if this makes sense. So if my smudge is found is equal to false, then if it is equal to false, then I found it. But if I found it, then if I found it before and I found another difference, it's the second difference. It's not as much. Then in the end, I will only add if I found my smudge along the way, because otherwise I could be tripping over a real reflection without smudges. And should I continue the borders exploration? No, I should not. There.
So by doing smudge found, you only count it once. And then if you find another one...
I bail out early.
Yeah.
Now rinse and repeat, folks.
Wait, hold on. Yeah. Very nice. Very efficient code.
People. 400.
Wow.
400. We are on the leaderboards
impressive.
of our own. We are playing with ourselves here, but... And folks, this has been day 13. Let's count our blessings and go to bed, because tomorrow there will be more of these. So, David, do you want to do it in the morning or in the evening?
Let me just check what I have on tomorrow. If I'm not mistaken...
This isn't a...
I-
I'm so happy.
I prefer... Yeah, you absolutely crushed that. That's great.
And there's more. David, we are over the first half. Congratulations. We are over day 13.
Ooh. Yeah, we are. That's lovely.
Time is flying.
Halfway there. Time is flying. It's going very, very well. Yeah, I enjoyed that.
Hello, Not
love
Was
that.
One. Hello, Nick. I will be reading the
really
chat
nice.
while David is checking his calendar. I'm going back 28 minutes now and trying to catch up. Congrats on getting day 12, part 2. Indeed, David, you are the best. I also solved day 12, part 2 by the same way. So, good thinking, everyone. I love functional programming. I love memorization. I love pure functions. I did I did programming language theory in a lab that does functional programming, OCaml, Haskell. I wrote some code to pack the data into up to 5 unsigned integers of 64 bits, which makes the caching and lookup fast, so it completes instant for me as well. Well, I am using strings and JSON stringify. Day 13 was fun too, though the relative indices solution that I made gave me such a headache, which I guess is the solution that I came up with. or we came up with, really. No, that's not what it says. Reflection is something that perfectly repeats to one edge. Time to move upstairs at live. 8 minutes to catching up, back catching up. Be able to catch up. I hope you catch up by now. You're blazing past this. It only took me 2 hours to code a much more complicated approach this morning. Part 2 was very easy for my approach though. Yeah, same here. Well done and goodbye. Goodbye, Nod was one. And David, tomorrow, 10 a.m., 10 p.m. or
10 a.m.
10 a.m. you say? Oof.
Yes,
okay,
please.
so go to bed, everyone, because we're back here 10 a.m. for more of Advent of Code, day 14. Thank you, Nick and Nod was one for joining us on the chat. Thank you to everyone else who's watching this. Thank you, David. You are a beast. You are the master of Advent of Code here. I'm so happy about your solution to day 12. And I'm looking forward to seeing you again here tomorrow morning.
Me too. I'm excited as well. See you tomorrow.
Bye.
Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.